class. I didn't have time in the classroom to finish the topic, right? So let me show you another two examples. Let me give you the homework already. The homework will be this: to solve the exercise section 5A and the investigation number 3, all of this 9, and then the exercise 5B, which is this one. Okay, so 5A, 5B, and all of these examples in here. Okay, just pay attention to the instruction and take a look at this. It's not necessary to do this table, not necessary. All I want you to do is find the asymptotes in these functions if there are any. Let me exemplify the two cases that we didn't get to see in class. So here we go. We already saw this case in which we have a rational function with variables in the numerator and denominator, and the variables appear at the same exponent, in this case 1. Okay, when that happens, you follow the trick that I showed you in class. Now when this happens, when also you have variables in the numerator and in the denominator, but the exponents are different, as you can see. Here we have a 1 and here we have a 2. You have to apply the trick of dividing, the one I showed you in class, but now using x squared. So here we go. Let me write the function f of x equals x plus 2 over minus 3x to the square plus 3x minus 1. So this is your function, and you're gonna first get the horizontal asymptotes. How do you find these things? By asking this question: what is the limit as x approaches infinity or minus infinity? It's basically the same, of your function, which is all of this, minus 3x to the square plus 3x minus 1. You're asking this question. How do you solve it? You apply the trick. Let me work in yellow. You apply the trick that I showed you, the same trick. The only difference is that you will divide over x squared, which is the variable at the highest exponent that appears in the rational function. So let's do it. X plus 2 over x squared over this trinomial. This is 2 over x squared, right? Perform this division and simplify. So in other words, arrive at the following. You're gonna be getting 1 over x plus 2 over x squared over minus 3 plus 3 over x minus 1 over x squared. Arrive to this after the simplification. You should arrive to this exactly. Let's continue here. So this limit now is ready to be taken. Let's take the limit. That's a very common phrase in mathematics. Take the limit. Like start the process of approaching x to infinity. What's going to happen? Let's see. We're going to analyze each of these numbers. So as x grows towards infinity, this will grow to 0. This will grow to 0 as well. Nothing will happen to this number because it doesn't depend on x. So this stays. This will also grow to 0, all of this fraction, and as well as this fraction. So as you can see, guys, when we take the limit, we have the following. The limit as x approaches infinity of all of this stuff will be 0 plus 0 over minus 3 plus 0 minus 0, which in the end is 0, right? So that's it. This is your answer. This is your horizontal asymptote is equal, well, colon, y equals 0. This is the horizontal asymptote of this one. Now, what about the vertical asymptote? Vertical asymptote. How do I answer this question? We should answer this. For what value of x do I get that the function grows towards minus infinity or plus infinity. I'm going to write this way. For what value of x do I get that the function grows towards minus or plus infinity? Remember, we're working with this function. And for that to happen, we need the denominator to be 0. If for a specific value of x, this denominator becomes 0, then that specific value of x is the one that will produce an output in the function of minus infinity or plus infinity. So what is the process? The process is this. I'm going to write the function in here. F of x equals all of this again. And we have to look for the numbers, for the specific numbers that x should have, so as to make all of these equal to 0. So that's the question, guys. I need to find for what numbers of x, for what values of x, this thing, which is the denominator, becomes 0. Let's multiply by minus so I can have a better equation, better looking equation like this. I don't like to begin an equation with a minus. That's just me. And let's try to solve this equation. Can we factorize that stuff? It's gonna be like so. I don't know. It doesn't have a factorization. 3 times 1. Nope. Nope. So what can you do? You can use the general formula, right? Let's find that value of x. So x gonna be minus b, which is minus 3, plus minus the square root of minus 3 to the square, minus 4a, which is 3 times 1 over divided by 2 times 3, and just simplify this thing. 9 minus 12 over 6. Okay, so what we can see here is that this is not a real number, right? Not a real number. You see, guys? X is not going to be a real number. So basically, the question that we asked is this. For what values of x do I get a 0 in the denominator? And this process of solution tells me, basically, there is no such thing. There is no such value of x for which this is 0, and therefore nothing will produce an output of infinity in this function, guys. No value of x will make the function grow either towards minus infinity or plus infinity. So conclusion, the vertical asymptotes don't exist. Don't exist according to my analysis, because I couldn't find the answer to these questions. You see, it doesn't exist. So let's see if I'm correct. So let's see. Remember, the horizontal asymptote was 0 and the vertical asymptote does not exist. So let's see if that's actually true. Let's graph this thing. Let's go to Desmos. What was the function? Once again, x plus 2. And minus 3x squared plus 3x minus 1. Like so. So I think I made a mistake. Minus 3x squared plus 3x minus 1. X plus 2. So we do have, no, that's right. I was getting confused. You know, if you look at the graph like this, you may think that there is a vertical asymptote over here, right? And I thought I had made a mistake. But if you do this, then look at this. You see, the function never grows towards either negative infinity or plus infinity. You see, it grows it decreases very quickly over here, but then it goes back to normal. You see, and the horizontal asymptote is indeed 0. You see, so this is the confirmation. This is the confirmation of what we did analytically in all of this process. Okay, now Now, okay, that's so this type solved. This is the type that we saw in class. This type solved. You just saw me doing it. And when we have this other type of rational function in which the highest exponent appears in the numerator, okay, you're gonna do the same trick. You're gonna ask the same questions for the horizontal asymptote and for the vertical asymptote. And now the trick will be dividing, in this case, dividing over x to the cube, over x to the cube. Do it. Do it. Try to answer both questions for the horizontal asymptote and the vertical asymptote, and I'm not going to tell you what the answers will be. I want you to think about those answers, okay? And then you can check graphically, all right? And do the same for all of these other six. And I remind you, exercise 5A and exercise 5B for homework for the next class. All of this is for the next class. Okay, thank you guys. Have a great day.